Okay, so good evening, and what am I playing with today? Well, I got in the post a couple of cheap and cheerful lasers with driver boards, and yes, we all love playing with lasers, and I was just having a look at these cheap things, and they were cheap, not expensive at all. I think they were both less than £10 each. This was the more expensive of the two, and I can only imagine because it's a slightly bigger machined component, and it runs off a higher voltage and has a slightly better control board. All I've got here at the moment, as you can see, it's a red laser, and I'm using the side of the multimeter here to just show the fat dot. This is described as a fat dot for stage lighting effects, and been messing about with ways to drive it. Now, obviously, all I've got here is power supply coming in, 12 volts in, through into the driver board, which then goes to the laser module through the constant current supply, and here we have just the fan supply, which is a small fan on the back of the heatsink to keep the diode a little bit cooler. What else have we got? Well, we have this input here, which is a Ttl Input, which stands for transistor to transistor logic, which is basically an on-off switch. And at the moment, with nothing connected, it's just in the on state. But what I've got coming in on these two wires is a 5 volt on-off signal from my signal generator. So if I connect this up, and we've got the signal generator set to quite a low frequency, it's about as low as Okay, I thought I'd insert this in as a separate bit of footage. I've recorded the main footage already, and I thought I'd add this in. Word of caution: when you are playing with lasers, you should wear safety glasses, and you should never look at the beam. It's marked on these diodes, danger, do not look at the beam. And even though these are relatively low power lasers, it's not a good idea. I already have failing eyesight due to my age. I don't want to damage it any further, so I'm not going to look into the beam. I'm not going to reflect it into my eyes. I'm not going to do anything stupid like that. And because I wear glasses that do slight magnification, I don't want to concentrate a very concentrated beam into my face. So when you play with lasers, be careful, wear the safety gear, be sensible. It's not funny to be blind. Yeah. Anyway, let's get on to the main footage without sounding too miserable. Here we go. It'll go. It's about 6 hertz. As you can see, we've now got a flashing dot, and if I vary the frequency, bring it up a bit, the dot flashes faster and faster until it becomes what effectively looks like a constant beam, even though it's flashing at quite a fast rate. Now, the maximum that these boards are meant to take is about 20 kilohertz, which is quite easy to achieve with separate TTL logic boards. Transistors can switch and MOSFETs can switch into the megahertz range, so you don't actually need any sort of vast complex switching. But the whole point of the ability to turn the beam on and off without actually interrupting the supply is so that you can actually change the beam pattern when it's reflected. So if you wanted to blank off while it was drawing a line. If you were reflecting it off a mirror and scattering it from a moving lens or scattering it from a moving mirror into a straight line, you could then change that straight line into a series of dots, because you're switching it on and off quite rapidly and spreading it over quite a large area. And you can do in software, obviously connected to some controller or other. You can do it in software, so you can activate the mirrors to reflect in certain directions, as well as to switch the beam on and off. So you could actually make some reasonable, say, light shows with writing. You could actually get it to switch on and off, so you'd have individual letters, as opposed to like the old Etch-a-Sketch where you had a joined line between each of the letters. So that's the advantage of being able to switch the beam on and off. So I'm just going to bring the frequency generator back down to as low as it'll go, and I'll fire up the other one and just make sure that that works in the same way, and see how it goes. So let me just first of all, I'm going to turn off the power supply and let that discharge like so. I'm going to pull the TTL logic out, and at the moment I'm using cast off component pins from another project, so let's just put these bits of wire in the plugs. I could use proper plugs, but I couldn't be bothered to look for any, if I'm going to be honest. What I will do though is I will check that this is the right way round, which one is the common pin and which one is the... So that's negative there, which connects to there, which connects to there, which connects to there, which connects to the white one. So the white one is ground and the blue one is positive in this case. Okay, so let's put the beam there. I'm going to unplug the supply, wasn't I? I'm going to need the power supply, otherwise it's not going to work. Okay, right, now this supply is meant to work from 5 volts, so in fact what I'm going to do is I'm going to take this one completely out the way so that we get a much clearer, come on, out you come, clearer workspace. So let's plug that into there, that into there, and that should be our so we're now flashing the LED because I've connected it across the other side. So it looks like the TTL input is a little bit too high for that particular thing, but there we go, we've got the dot. So that's just showing the flashing from the signal generator and the dot there. So again, we can vary the frequency. I'll bring the frequency up and change the pulse width of the thing. Now it's not true pulse width modulation because you're not actually setting a voltage at a varying average level. You're either switching it on or off, which is what TTL is. So let's bring it back down to there, and just to show you that this is quite a low power laser, I'm going to stick a match head in front of the beam, and it should just be perfectly safe and not actually do any damage if I keep the beam constant. As you see, you know, nothing is happening. We are in the beam, even though it's flashing quite slowly. Let's bring the beam right up. And it's now flashing so fast the LED looks like it's constantly lit. And again, the match still doesn't light. So, you know, you can't say these are burning lasers in any way. These are just designed for light shows and effects like that. I'm not particularly interested in setting things on fire anymore. I grew out of that quite a number of years ago, and now we just like making pretty light shows. So again, this is something that I'm looking to sort of experiment with. I didn't want to spend vast amounts of money on, professional systems and high quality lasers without grasping the basics first. And this is just giving me sort of the basics of, how to modulate the lasers. I will get around to coding an Arduino to do the on-off switching and, working out some sort of reflective mirror system, and just trying to get, pretty patterns out of what I've got, rather than saying, oh well, I'll just go and buy something that's ready built, because that just defeats the whole point of the object, doesn't it? So there we go. 10 minutes on cheap Chinese lasers. Thank you very much for watching, and hopefully we'll see you again soon. Bye bye for now.